Hello. So in this video we're going to look at the horizontal changes that are affected, or that do affect the graph of sine and cosine, and that's going to be the effects of B and C inside the argument of the sine and cosine. All right? So let's take a look at this example. Y equals cosine of 2x minus pi over 4. But let's say the directions say that they want to see, this is actually an infinite wave that goes on and on forever, but we want to see that portion that goes from negative pi over 4 to, let's say, 3 pi over 2. Okay? Alright, so how do we figure that? Well, we start out with one wave. So I'm going to do both methods again in terms of solving for the period and the phase shift and the end of the wave. So you get a little accustomed to both. Alright, so I want to know where 2x minus pi over 4 is going to go to 0. What x causes that to happen? Find the beginning of the wave. And then I want to know for what x would I have this be 2 pi, the end of the wave. Alright, so when I force this, the argument, to go from 0 to 2 pi, then I know I generate the cosine wave, and really what I'm doing is finding out what x will make that happen, so I'm solving for that. Alright, so here I would have 2x equals pi over 4. And now I take half of both sides. And so x equals pi over 8. Right? Now over here I would have 2x equals 2 pi plus pi over 4. So 2x equals, now getting a common denominator here, I would multiply by 4 over 4. So I'd have 8 pi over 4 plus another pi over 4. So 2x equals 9 pi over 4, and now I multiply by half to get rid of this 2, oops, half here. So now x equals 9 pi over 8. So this is where the wave begins, this is where the wave ends. And the period is end minus beginning. So 9 pi over 8 minus pi over 8 equals 8 pi over 8, which is pi. So the period is pi with this method. Okay. Now, with the second method, we're going to use formulas. So we're going to say the period is 2 pi over b, which is 2 pi over 2, and it's pi. So this pi corresponds to this pi. Now the phase shift is negative c over b, so that's negative of a negative pi over 4 divided by b, which is 2. So I'd have pi over 4 divided by 2, which is flip and multiply pi over 8. All right. So that's my phase shift, and now the end of the wave is equal to my phase shift where I begin the wave plus the length of the wave, which is the period. So pi over 8 plus pi, which is pi over 8 plus 8 pi over 8, which is 9 pi over 8, is where the wave ends, and that's what we got here. So whichever method you use, you're going to get the same things. All right, so now let me go ahead and draw at least one wave, and then we can go back and find either the quarter points and then extend things. All right, so let's go ahead and draw one wave. So we would have, let's see here, let me go back here, kind of put it about here. So we know we begin at pi over 8 and end at 9 pi over 8. So here, let's say, is pi over 8, and we'll just say that this is 9 pi over 8. And then when I'll say this is 1 and this is negative 1, and then I'm going to divide this into fourths and go ahead and draw out my cosine. I start at a max, go to the axis, then go to a min, go to the axis, go to a max. And then let me go ahead and fill that out. There we go. So that's one wave. Now, we can do this a couple ways. I probably do the quarter points last. I'm going to go ahead and address how do I get this wave to see that portion of the wave, because technically this wave goes on forever and ever in both directions. We only want to see a portion of it, from negative pi over 4 to 3 pi over 2. Well, I know that the period is pi, and then that means in that distance I'll see one cycle or one wave. So if I just keep adding pi and subtracting pi until I cover this interval, I'm fine. So now let's see a little bit about that interval. This interval, notice that we're working in pi over 8ths, and that we want to work in pi over 8ths and see what does this really equal in pi over 8ths, because this is what we're seeming to get. So negative pi over 4 is the same thing as negative 2 pi over 8. And then 3 pi over 2, if I multiply by 4 over 4, is going to give me 12 pi over 8. Right? So as long as I can see this much of my wave, I've shown the interval that we're being asked for. So now let's see what that means. We're starting at pi over 8. So now if I subtract the period pi, that means I'm going to take this wave and make it go and show another wave going in this direction like that. So that's a distance of pi, so I take this value, pi over 8, and subtract the period. So let's see what we'll get. Pi over 8 minus the period is going to be pi over 8 minus 8 pi over 8, right? Pi. So I'm going to get negative 7 pi over 8. Right? So the idea is, let me kind of make this a little bit accurate here. So if I'm about here, I should be at negative 7 pi over 8. And I know that if I divide this into 4 equal parts, I should see a full wave. So let's take a look. All right? And then I'll have here, and I'm not sure that I'll really go through 0. I'm not sure exactly where this fourth part is. So maybe I should be doing my quarter points before I fill that in. But basic idea is I'm going to have to go back at least this far. And will that go farther than I need to? Well, yes, I only need to go to negative 2 pi over 8. So I'm already back here at negative 7 pi over 8. Negative 2 pi over 8 is somewhere in here. So I will have shown what I needed to show. So now let's go the other way and take the 9 pi over 8 and add the period, right, get another wave, and see if we exceed 12 pi over 8. So then we'll say 9 pi over 8 plus the period, a cycle, will be 9 pi over 8 plus 8 pi over 8, which is 17 pi over 8. Okay. So that means if I take this and kind of visually see it there, this is 17 pi over 8, right? And again, I'll see another wave when I go, 4 parts, go like that. And does 17 pi over 8 exceed 12 pi over 8? Yes, it does. So we're going to be fine, and we'll see enough of the wave. Now let me go ahead and fill in these quarter points. Let me find out what they are. So let me take another, well, I guess I could use this page still. So let's do the quarter points. So this handled the interval. And by the way, if this hadn't been enough, I would just keep adding another period and adding another period or subtracting another period until I finally passed this value, the endpoint values, either going positive this way or negative going that way. All right, so now let's take a look at our quarter points. All right. I want 1/4 of the period is 1/4 of pi, which is pi over 4. Let me go ahead and make that 8s because I know I'm working with 8s. So that's 2 pi over 8. So I'm starting at pi over 8, and I add 2 pi over 8 to get 3 pi over 8. That's my first quarter point after I begin. Then I take 3 pi over 8, and I add 2 pi over 8. I get 5 pi over 8. And I take 5 pi over 8, add another 2 pi over 8, and I get 7 pi over 8. And finally, I take 7 pi over 8, add another 2 pi over 8, and I get 9 pi over 8, which is our ending value. So we're doing well. That's our check. That's like, yep, we did it right. So what that means is I could now label here. This is pi over 8. Then we go 3 pi over 8, 5 pi over 8, 7 pi over 8, 9 pi over 8. So this is 3 pi over 8, 5 pi over 8, 7 pi over 8, and then 9 pi over 8. So I got those, and if I want to, I can go ahead and label that pi over 8 1, 3 pi over 8, 0, 5 pi over 8, negative 1, let's see, 7 pi over 8, 0, and finally 9 pi over 8, 1. Okay? Now let's find these values in here. Well, I'm basically going to keep subtracting the quarter points, which in this case, a quarter of the period is 2 pi over 8. So if I do that, what I'll see is going this way, I'll have 3 pi over 8 minus 2 pi, I'm sorry, here, pi over 8, where to begin, pi over 8 minus 2 pi over 8, right? So pi over 8 minus 2 pi over 8 is going to give me negative pi over 8. So I know that I'm, let's see here, I'm probably about here. This is not exactly accurate, unfortunately. I'm going to have to put that in there, though. It's not really a fourth. There's the other one. And then negative pi over 8 minus another 2 pi over 8, because I'm going in that direction, and I keep subtracting a quarter of the period. It's going to give me negative 3 pi over 8. So this is negative 3 pi over 8. And then I take negative 3 pi over 8 minus 2 pi over 8. And I get negative 5 pi over 8. So this is negative 5 pi over 8. All right? And so, of course, I could just now fill this in and say this goes to a max, 0, over here a min, back to the axis, and then back over here. So here we go. Okay. If I had just slightly better spacing, that would look a little tad bit better, but that's the basic idea. Now let's go in this direction. My first wave ended at 9 pi over 8. So 9 pi over 8, add the, instead of subtracting, I'm going to add 2 pi over 8, the quarter of the period. So I'm going to get 11 pi over 8, and then 11 pi over 8, plus another 2 pi over 8, 13 pi over 8, 13 pi over 8, plus 2 pi over 8, 15 pi over 8, finally 15 pi over 8, plus 2 pi over 8 is 17 pi over 8. So we're at least here. So what that means is I have 11 pi over 8, 13 pi over 8, 15 pi over 8, and finally 17 pi over 8. So if I went ahead and drew this, I would say I start at a max, go to the axis, go to the min, go to the axis, go to the max, fill that in. Okay. Now let's look at our interval. It was from negative pi over 4 to 3 pi over 2, but converted to the same denominator, it's negative 2 pi over 8 to 12 pi over 8. So where is negative 2 pi over 12 to 12, I'm sorry, over 8 to 12 pi over 8, right? That's what I'm looking for. Well, here I have negative pi over 8. Here's negative 3 pi over 8. Let's see if we can. It's going to be right in the middle of that, right? Between negative 1 and negative 3 is negative 2. So I want this portion of the graph right there. And then I got to go to 12 pi over 8, which is going to be between 11 and 13. That's here. So I'm going to like this. So although this wave goes on and on and on forever and ever and ever, so you'd have this kind of thing, right? We only want this portion of the wave right there because of the interval that we were given. Okay? Thanks for listening.